Hey everyone, welcome to The Explainer. Today we're embarking on a real cosmic detective story. We're going to trace the history of our cosmos back 13.8 billion years to uncover a hidden, honestly almost unbelievable truth about the very fabric of reality. We're going to pull back the curtain on the deepest, most ancient mystery of the night sky. And what we find, well, it might just change the way you look up at the stars forever.
Okay, let's dive into this. What was the very first color of the universe? It sounds like a pretty simple question, right? I mean, when we step outside tonight, our modern night sky is overwhelmingly black. It's just this endless, dark void punctuated by tiny pinpricks of starlight. So, how could scientists possibly determine a color that no human eye was ever actually around to see?
Section 1. Những manh mối cổ xưa, or ancient clues.
To answer this mystery, we don't actually start at the very beginning of time. We start right here, today, 13.8 billion years after the Big Bang, with a sort of ghostly whisper. All around us, literally permeating every single inch of space, there is a faint, invisible bath of energy. To understand this ancient clue, we need to travel back to a very specific, completely alien era, the 380,000-year mark.
So that ghostly whisper we detect today, it's officially called the Cosmic Microwave Background, or CMB. It is quite literally the oldest light we can possibly observe in the entire universe. It's this ancient, awe-inspiring glow captured by our modern radio telescopes. But to understand what this light is trying to tell us about the very first color of the universe, we have to look at the extreme conditions that actually created it.
Section 2. Bức màn sương mù, the fog.
So the crucial point is, if you could somehow survive traveling back to this era, you wouldn't recognize a thing. The universe was unimaginably hot, like we're talking billions of degrees. It was a violent subatomic soup where protons and electrons were zipping around with so much thermal energy they just couldn't bind together. Because these electrons were roaming free, they acted like a brick wall for light. Photons were constantly crashing into them in a process called Thomson scattering. Light was just completely trapped.
Try to imagine placing yourself inside this era. It wouldn't just be a thick fog. It would be a blinding, featureless, white-hot fog. Your eyes would be completely overwhelmed by an intense brightness coming from absolutely every direction. There were no shadows, no shapes, and definitely no distinct colors as we think of them. Just an agonizingly bright, opaque plasma everywhere you looked.
Section 3. Kỷ nguyên tái tổ hợp, the recombination era.
But you know, the universe wasn't static. It was continually expanding and cooling, building this incredible tension for nearly 400,000 years. And the magic number it hit? Exactly 3,000 Kelvin. As the temperature finally plummeted to this specific threshold, the universe was about to undergo a massive phase transition. It's kind of like steam condensing into water, but on a mind-boggling cosmic scale.
This turning point is known as recombination. Now, don't let the dry physics term fool you. This was a moment of grand liberation. The universe finally cooled down enough that protons could pull in those frantic, fast-moving electrons. For the very first time in cosmic history, the electrostatic attraction overcame the heat, and they locked together to form stable, electrically neutral hydrogen atoms.
Let's move along and see how this builds, because this triggered the most important visual event in history. Because neutral atoms formed, those pesky free electrons that were acting like a solid wall, they completely vanished from open space. They were now locked away. And suddenly, the cosmic fog just cleared. The universe became transparent. Light could finally stream freely across vast distances. It's like the lights of the universe were finally turned on.
Section 4. Khi vũ trụ màu hồng, the pink universe. Now, what's really interesting about this is how the visual recipe comes together. As that opaque fog lifted, what did that newly freed light actually look like? Well, it comes down to two things. First, that uniform 3,000 Kelvin heat emitted thermal radiation peaking right in the visible to infrared spectrum, which created this brilliant orange-white base. But as those electrons bound to protons, they cascaded down energy levels, releasing very specific wavelengths of light. The strongest of these, H-alpha, is a brilliant, deep red mixed with just a touch of cyan.
When you synthesize these phenomena, that intense orange-white thermal background and the brilliant pinkish-red flashes of hydrogen atoms forming absolutely everywhere, you get a breathtaking visual. Every single cubic meter of space was glowing. The entire sky, in every single direction, was a vibrant, saturated orange, beautifully tinted with a deep red-pink hue. This was the pink universe. For a brief cosmic moment, space wasn't black. It was a brilliantly glowing pinkish-orange canopy.
Section 5. Lời giải mã khoa học, the scientific decoding. Obviously, we look up today and the sky isn't pink anymore. So where did all that beautiful light go? The answer lies in cosmological redshift. Over the last 13.8 billion years, as space itself expanded, it literally stretched the light traveling through it. That intensely bright pink-orange light was stretched over billions of years, its wavelength shifting past red, past infrared, all the way into the invisible microwave spectrum. Believe it or not, it's still hitting the Earth right now. Our eyes just can't see it.
We know this for sure thanks to incredibly precise modern detectives, satellite missions like COBE, WMAP, and Planck. COBE proved that the background radiation perfectly matches the thermal profile of a cooling universe. WMAP and Planck then mapped this ancient light with stunning precision. These satellites essentially unredshifted the microwave data by a massive factor of 1100. They mathematically rewound the expansion of the universe to definitively reveal that 3000 Kelvin pink-orange origin.
What's super fascinating is how this contrasts with our cosmos today. The early pink universe was perfectly uniform, fiercely bright, and driven entirely by raw thermal heat. Today, researchers have actually averaged the light of all the billions of galaxies currently in existence. Because our modern universe is vast, sparse, and dominated by older, redder stars, the average color today is this pale beige hue, affectionately known as cosmic latte. We've gone from a blinding, majestic, uniform pink dawn to a sparse, dark, pale beige composite. So, the next time you step outside and look up at the dark, silent night sky, consider this. That blackness, it isn't just an empty void. It is the stretched, faded ghost of a brilliantly pink universe. The dark sky is just an optical illusion created by the expansion of space itself. You are quite literally standing in the fading echoes of a pink dawn. It really makes you wonder, as our universe continues to expand and cool, what hidden colors might be waiting for the observers of the far future.